Hello everyone and welcome back to another video. My name is Dylan and in this one I have got a lot of questions. This is a mega guide to fractions, decimals and percentages. I've got loads of questions from the past. I'm going to give you the top tips you could possibly get. Let's dive straight in because to be honest with you, we've got a lot to cover. I've put this in first because knowing these equivalences between the fractions, the decimals and the percentages, it's vital, okay? That's all I can say really. And the best thing to do is to learn them. So for example, 1/4 here is equivalent to 0.25. You could work this out. You could change 1/4 to out of 100, multiply the denominator by 25, do the same to the top, get 25 out of 100, work it out. But really, we should just know this fact. 1/4 is 0.25, and once we've got it as a decimal, turning it into a percentage is truly quite easy. 0.25 is 25%. Same here for half is 0.5. This is a more commonly known fact. It is the 1/4 and especially this one here, the 3/4. This is something a lot of children get muddled up with. And it's clear to see why, because we've got a 7 and a 5 and a 3 and a 4. And none of these numbers seem to go together. But if you were to make this denominator 100, multiply it by 25 and do the same to the top, you would end up with 75 out of 100, which is 0.75. Once we've got that, like I said earlier, the percentages is easy. What I would say out of all of these, the top three, they are vital. Okay, there's just no wiggle room there. You should just know those. But I would also advise learning the rest here. For example, 1/10, we learn this in year 4. Okay, and that's what these Key Stage 2 SATs do. They teach you, test you on everything you've been taught. So we should know this one as well. And if we don't, again, we can use place value. After the tens and the ones, there's a decimal place, and then we go into the tenths. So 1/10 would be 0.1. And we put a placeholder in here, 0.1. And 0.1 here is 10%. And then down the bottom, 1 out of 100. Well, that's the easiest percentage we can do because that's 1 out of 100, 1%. Percent literally means per 100. And down here, we'd have to think about where that 1 would go. It would go in the hundredths column. So we need a placeholder in the tenths and we get 0.01. Those first 5, par for the course. These next 3 are bonus, okay? If we can know these, we're in a really good position. 1/5. 1/5 is the same as 20%. Now, again, you can work this out, and you might be expected to in some questions, but if you know this link straight away, then it can save you time. And once you know it's 20%, therefore it's 0.2. And I've just done these the wrong way around. Not that it matters too much because they're still equivalent. Down here, 1/20th, again, 1/20th. If we're thinking to write it as a percentage or as a decimal, we should be aiming to get that denominator to 100. How many 20s in 100? Well, that's 5. So if I multiply the denominator by 5, do the same to the top, and I get 5 out of 100, which is 5%, or 5 hundredths is 5 in the hundredths column, 0 in the tenths as a placeholder, and then 0 point, so 0.05, and 1/8. This one is just annoying because we can work it out. 1/8 is half of a quarter. So if we take 0.25 and half it, we get 0.125, and we end up getting further down into those decimals. It's trickier to work out. It's doable, but what I would say to you here is, for a percentage being 12.5%, my advice for this would be learn these. If you know these off the top of your head, it just frees up so much more time later on. Okay, so that's the first thing I wanted to say about decimals, percentages, and fractions equivalents. Learn these facts. Take a screenshot right now and learn them because I promise you it will come up in some form and it will help you. Now I wanted to look at some arithmetic. I'm going to whiz through some arithmetic questions and then a bit later on, stick around because I'm going to go through some really tricky problem solving. Like I said, this is a mega video, so if you can watch to the end, you're going to be rewarded, that's for sure. 4/6 multiplied by 1/8. When we're multiplying fractions, it's very simple. We just multiply the numerators together and we get 4, and we multiply the denominators together. 6 times 8 is 48. 4 out of 48 would get you a mark. Done. You could simplify because 4 is a common factor of both. Divide the numerator by 4, we get 1. Divide the denominator by 4, we get 12. So 1/12 would also get us a mark, but so would 4/48 because that is correct at the end of the day. So you'd still get a mark for that one. When we're adding fractions, again, in year 6, in these Key Stage 2 SATs, we're really looking at different denominators. So whenever we add fractions, we want the denominators to be the same. So I'm looking for a common multiple of 3 and 5, a number that's in the 3 times table and in the 5 times table. And a good way to do this is to just multiply 3 and 5 together. We get 15. So I've multiplied 3 by 5. I do the same to the top, and I get 10 out of 15. Add, and I'm going to change 5 in this denominator to 15. To do that, I multiplied by 3, do the same to the top, and I get 12. 10 plus 12 now, because the denominators are both the same, we can just have 15ths, and 10 plus 12 is 22. 22 15ths, and if we wanted to simplify it, we could put 1 whole and 7 15ths, because 1 whole in this case would be 15 15ths, Take that away, we're left with 7/15 at the end. We've bridged past 1. Not that it matters because both of these answers are correct. We cannot argue with them. They're right. Now with subtraction, it's the same thing. We want these denominators to be the same. But this question, we should notice that 21 is already a multiple of 7. So we don't need to change this fraction. We can keep it as 11 over 21 because we can change the first one instead. So less work for us to do. To get from 7 to 21, we multiply by 3. So do the same to the top. 6 3s are 18. Now I'm left with a very simple question because the denominators are the same. 18 take away 11 is 7. I'm left with 7 out of 21. And look again, you can simplify this, divide both by 7 to get 1 out of 3. Both are correct. You're going to get the mark, okay? So be very careful with what you choose to put down in this paper because we need a correct answer. And both of those are correct. Now, when we're dividing by a whole number, something to think about here, I'm going to write it out again. 7 out of 10 divided by, and the reason I'm writing it again is because we can think of 2 as 2 over 1. 2 divided by 1 just stays as 2, right? So we can think of 2 as the numerator here. And the rule when we have division is we cross multiply, we flip. Okay, you may have heard of KFC, keep, flip, change, all that kind of thing. Like, there's loads of different acronyms and things out there for different ways of doing fractions. The way I teach it is just simple. If we see division, we can multiply across once we've flipped the fraction. So here, 7 over 10 divided by 2 over 1 is the same as 7 over 10 times 1/2. Once we've done that, we remember from earlier, it's very easy. We just multiply the top, we get 7. Multiply the bottom, we get 20. Because remember, if we're dividing by 2, we should be getting smaller. So 7/10 is actually greater than 7/20. We do still get smaller, and that will get you the mark. Let's look at another arithmetic. We've got a couple more, then we're going to go into that problem solving. Stick around, it's going to get tricky. 2 and 3/8 take away 5/8. So this is a really good question because 3/8 is less than 5/8. And luckily for us, we've got both denominators the same. So I can start to take away 8s immediately. I'm going to actually take away all 3/8. I'm going to get rid of it. So because I've taken away 3/8, I've actually only left with 2 8s to subtract. Does that make sense? I've taken away 3 of these 8s already because I got rid of my 3/8 here. So now I've only got 2 8s left. That means my answer is going to be 1 whole, and I'm going to take 2 8s away. So if I've got 1 whole on top of my 1 here, and I take away 2 8s, well, 1 whole I can swap for 8 8s, take away 2 8s, is 6 8s. So I've got 1 and 6 8s left. Again, it's just tempting you there, isn't it? Just to change it and simplify it. You can do, this is correct. You could change it to 1 3/4. Both are correct in this instance, okay? So just be careful when you're subtracting past a whole number. Be careful that you take away the right amount, in this case of 8s. We need to take away 5 in total, and we did. And we got to the right answer, and we got the mark. 1/2 divided by 3. Again, very similar to last time. 1/2, remember what we did last time? I'm going to flip it. So I'm going to say it's 1/3. Now I can do 1 times 1 is 1. 2 times 3 is 6. Did you get it that time after a couple of questions ago? Hopefully you did, because once you know that, these questions become so easy. And the last one I want to look at here is a classic one. This is from the 2024 SATs paper. 1 1/4 times 39. I'm going to split this. I'm going to do 1 times 39 because that's incredibly easy. That's just 39. And then I'm going to take this quarter out and I'm going to do 1/4 times 39. Now again, this is actually easy. The answer is 39 quarters. Okay, but what we can't do is say, okay, the answer is 39 and 39 quarters. No, we cannot do that. That would be incorrect. We need to give it now in its simplest form. So 39 and 39 quarters, we need to think, okay, how many quarters are actually in 39? So we count in 4s. And the closest we can get is 36. 36 quarters gives us 9 wholes. So we've got 9 wholes there. And with 36 quarters, getting up to 39 leaves us with 3/4 remaining. So we've actually got here 39 plus 9 and 3/4. 39 plus 9 is 48, and then the 3/4 sits on the end. And that's how we answer that question. We can split it up and simplify it into some simple terms. If you put 39 and 39 quarters, this is incorrect because we have whole numbers here and we have a fraction which is above 1, and we cannot have that mixture there, okay? This is the proper mixed number answer. We are going to move on now to those problem-solving questions, but first, a message to parents out there who would like just to let their children have a bit of a boost. We do loads of videos on our YouTube. They'll always be free to access. You can get on them right now, and it helps a lot. But we get a lot of messages asking for extra help, and here it is. On our website, we are Top Dog Tutoring, and we have made so many extra lessons for any children, year 4 and year 5, if it's looking for 11 plus bits, but you're here watching SAT, so probably for year 6, loads and loads of different questions here. We have maths and English all the way through. We've got time duration problems. We've got Shakespeare even in our English sessions. There's so much. Comprehension, loads of maths questions, arithmetic, reasoning, the lot. And the great thing is you can use this QR code now, or the link down in the description. Make an account on our website, which is completely free to do, and you instantly get access to some of those lessons, and you can try them out for completely free. They look like this. You get some video lessons just like these videos we're recording right now. You get a homework task with them, a PDF, and even a video walkthrough of that homework too. We're so proud of what we've created there. We do loads here on our YouTube and we'll continue to do that. But if you want that extra, sign up, scan this code. It's completely free to make an account, completely free to get access to some. And if you like it, well, you can get access to all of it. And I think it's well worth doing. Anyway, moving on now to some reasoning problems. These diagrams show 3 equivalent fractions, so you can see immediately this is going to be equivalent fractions because fractions, decimals, and percentages actually covers a huge range of different questions that can come up. So let's take a look. 3/4 is equal to 9 what? Well, we could just look at this if we wanted to and work it out using what we know. How many 3s are in 9? Well, we multiply that by 3. So for it to be equivalent, we do the same to the bottom. 4 times 3 is 12. But this question even gives us a picture to work from. And that might be much easier for some people to look at and work out. So we can see here, look, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, out of 3 more, which is 12, and we can just write that down. 24 here, again, you could just use your knowledge of 12 times 2 is 24. So do the same to the top to maintain equivalence, or you could have counted up here. Having a solid understanding of fractions, especially equivalence and how they work, means that you could answer this really quickly. But even if you're stuck, excuse me, hiccuping, even if you're stuck, you could have just counted. Always be on the lookout for those picture prompts when it comes to answering fraction questions in that reasoning paper. Let's take a look at this one now. This is again comparing fractions. And this is where I would say it's a perfect example of fractions and decimals being put together. And your knowledge of being able to interchange between them will rely on answering this question. So for example here, 0.07. We should know that this is the hundredths column. So this is 700ths, and you could write it as a fraction, 700ths. Now, what I would say is comparing 2 fractions is much more likely to lead to a misconception. For example here, 7 and 7, you might think it's equal. The answer is not equal, of course. The best way to compare numbers is to make them both decimal. So I'd go to the left, and I would use my knowledge of place value. I'd put 7 in the tenths column, which is here. The decimal place would go there, and I'd have 0 point. Now, this is much easier to compare, because 0.7, I could put a placeholder in the hundredths and have 0.70, compare it to 0.07. Clearly, 0.70 is larger, and I do the greater than symbol. Same down here. I'd be changing it into decimals. They're much easier to compare. I have 23 thousandths. Okay, I have tenths, so my decimal's going to go here. Hundredths and thousandths. Now, I know I can't fit two digits into one column in my place value chart. I can't put 23 in here. So I have to put the 3 there, and the 2 would move up. Okay, but importantly, if I just stopped there and said 0.23, you might think it's equal again. No, no, no. In the tenths, we put a placeholder, 0.023. So there's 0 tenths in this number and there's 2 tenths there. We can stop comparing straight away. The one on the right must be bigger. So it's vital to be able to change fractions when they're tenths, hundreds, and thousandths really quickly into decimals, which is nice because they match up with our place value chart. Then we can compare them and get the answer right. Let's take a look at this one again. This is to do with, sure, can you figure out what's shaded by counting? So in this case, we know that each column is 10, and it's 10 by 10, so this is a 100 grid. We have 10, 20, 30, 40 shaded out of 100 in total. So we know straight away we can tick that. That's not testing anything other than can you figure out what the fraction is. But it says tick the fractions, read the question carefully with an S, it's going to be multiple. So now what I'm really being asked is, can you find equivalent fractions the same as that? I'm going to tick 4 tenths straight away. The reason I'm ticking 4 tenths straight away is because we know these strips are tenths. There are 10 columns. So I've got 1, 2, 3, 4 columns out of 10 columns shaded. So these are equivalent. Again, you could have divided by 10, top and bottom, and got the right answer. But here is where most children will stop and go, okay, look, I've got it. It says fractions, more than 1, done. No. 2/5 is also an answer. And this is where we really do need to have a solid understanding of what makes fractions equivalent. 10 to 5 is dividing by 2. So if we do the same to the top, 4 divided by 2, I also get 2. Therefore, this is equivalent. Therefore, we must tick that box as well. So this is a real good question because it tests can you figure out what fraction of a shape is shaded. It also asks you to then think about your knowledge of tenths and how that might look in 100 square. But then again, just straight up equivalence. Loads being tested in one question here, and you can see why it's important to have a well-rounded view of all of these questions. This is straight up equivalence, okay? If you know how equivalence work, we looked earlier, didn't we, at a question, this one, where it gave you the pictures as well, and you could rely on the pictures. Here, you can't do that, okay? You need to know that for a fraction to be equivalent, whatever we do to the denominator, we must do to the numerator. 10 to 20, multiply that by 2. Do the same to the top, multiply that by 2, and we get 6. Done. Down here, 12 over 15 equals 4 over what? Well, this is where we need to understand we can also divide. Okay, it's multiply or divide. 12 divided by 3 is 4. Knowing your times tables is vital, by the way. So I'm going to do the same to the bottom, divide that by 3. How many 3's in 15? The answer is 5. If you know your times tables and how equivalent fractions work, you're going to get these questions right every time. Let's keep going. Tick the fractions less than 5/8. We're still in that realm of comparing, but we can see now how the test can put it into lots of different contexts. So 1/2. Is 1/2 less than or more than, greater than 5/8? Well, we have to put it into 8s to find out. 2's to 8 is multiplied by 4. Do the same to the top, we get 4/8. This is 4/8. That is less than 5/8. Tick it. 2/8, well, that's easy. They're both 8s, and 2 is less than 5. Tick it. 3/4. Okay, let's change that into 8s. Multiply the bottom by 2. Do the same to the top. 6/8 is not less than 5/8. Here, 16ths. Now, I could halve it to get to 8s, but my problem here would be halving 7's awkward. I get 3.5. I mean, look, you could know 3.5 over 8. You could know that's not a real fraction, but be able to tell that's obviously less than 5/8. Or another good way to do it could be to change 8s into 16th at the top. Double the top, we get 10. So the question becomes, tick the fractions less than 10/16, which 7/16 obviously is. And here again, we have 24 out of 32. We can change that to 8s. There are 4/8 in 32. Divide the top by 4, and we get 6/8. That is not less than 5/8. This is essentially asking you to work out equivalent fractions, but 5 times in one question. So you need to be a pro, and the quicker you can do it, the more likely you are to actually answer the question correctly. Now we see a question where we put fractions on a number line. There's a couple of ways to answer this question, okay? We could notice straight away this is 0 and this is 1, and we could count the jumps in between. That's a jump of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 intervals. So each jump is a 12th, 1/12, 2/12. This is 2/12, but of course the question doesn't give it to you in 12ths. It's testing your equivalent knowledge. 2/12 is the same as 1/6, so we can put 1/6 in here. There is another way to answer this question that's quicker. Now we could go through and do all the equivalents, but I've shown you how to do that. Here's a tip on how to answer this question more quickly. So looking up here, we know it's going from the lowest up to the highest, which is 1, so from 0 to 1. So if we know how to order fractions in a quick way, we can just get the answer right. And because all the numerators are the same, we can look at the denominators, which is how many parts the whole is split into. So if a whole is split into 6 parts, they're smaller. Then the next would be 4 parts. We can put a quarter in here. So we've done 6, we've done half. Sorry, we've done quarter. What's the next smallest? 1/3 or 1/2? Well, if you have a really solid understanding of fractions, you would know it's 1/3. And then 1/2 is the largest of all of these. The reason being, it's a trick really, because lots of children, again, look at 2 and think that's the lowest. 2 is lower than 4 and 6 and 3, so it must be the lowest fraction. No, in fractions, it's the other way around. If we only split our whole into 2 parts, that half there is quite big compared to if I have the same whole and I split it into 4 parts and I have one of them. Look, that quarter is obviously smaller than that half. If we know how to order them, we could just put them in order because we know it's going from smallest in ascending order up to the largest. Something that can really help you answer these questions quickly. I hope you find this useful. We've got a whole bunch of guys. This is worth watching, that's for sure. Which of these fractions, write these fractions in order starting with the smallest. Again, looking at this, I can actually answer this quickly. I put this in because, yeah, okay, we could change them all to 20ths. I've taught you how to do that, fine. But realistically, look at this. 3/5 and 3/4, that's less than 1. Okay, they're normal proper fractions. This is an improper fraction, 6/5. That's more than 1. So I know this is the biggest one straight away. So I start with the smallest, I'm going to the biggest, it's 6/5. Done. Now, out of these two, what's the smallest? Well, the numerators are the same. We've got 3 of each. So I've just got to answer this question. What's smaller, a 1/5 or a 1/4? Based on what I just said, obviously fifths are smaller because if I have 5 pieces, each piece will be smaller than if I have 4 pieces, and I put 3/4 in there. I've done that without doing any calculating, any working out. That's where a solid understanding of fractions, it will get you far. Let's take a look at this question and straight in now. Flipping it again, look, another way that we can use fractions in this test, fraction of a quantity. A book has 276 pages. Amina has read 1/3 of the book. How many pages are left? This is a classic question where it flips the switch halfway through. She's read 1/3, so I always draw a bar because it takes me 2 seconds and helps me visualize this. The whole book is 276, and she's read 1/3. So I'm going to put R for read. But the question says how many pages are left. So the question's actually asking for this 2/3 gap. So what I really need to work out is 2/3 of 276. Now, if I know fractions of a quantity, how to work it out, this is easy. Take the bus stop method, 276, divide it by 3. That'll give me 1/3. 3's into 2 don't go. 3's into 27 9 times. 3's into 6 twice. So we have 92 pages for each third. And the trick answer would be just to put 92. But remember, this is how many are left. So now we take 92 in this 2-step problem. We multiply it by 2 and we get 184 pages remaining. Read the question carefully. This is not a reading test. Let me just say right now, this is not a reading test. You can have these questions read out loud. Okay? You need to know that. If you're stuck on a question, sometimes just getting it read out loud is super helpful to have something just go click in your brain. A cinema sells tickets at 3 different prices. 1/20th at price A, 3/5 at price B, the rest at price C. What fraction is remaining? Now, this is the ultimate. Okay, I keep saying the ultimate, but this really is putting together so many different strands of equivalence. Because how on earth can I compare a 20th with a 5th? I just can't. So I'm going to keep A as 1/20th because I noticed something. I can change 5 into 20 very easily. So for B, I'm going to change it into 20ths. Now, 5 times 4 gives me 20, so I'm going to do the same to the top and get 12 out of 20. So now I can do 1 out of 20 at A, and 12 out of 20 with price B. That gives me 13 out of 20 altogether for A and B. So the rest, well, what do you mean the rest? How do I know what the rest are? Well, the rest gets us up to 1 whole. So now we have 1 whole, take away the 13 20ths, and what would be left over? Well, if your knowledge of a whole is really solid, which is a good place to be for fractions, you'd be able to swap 1 whole for 20ths. And if we know it's the full amount, it's going to be 20 out of 20. 20 take away 13 leaves me with 7 20ths, and that's the answer. Not too tricky, but you can see how, embedded in a word problem, different denominators, we can get a bit flustered in the test. Slow down. You got this. Everything we've done here, you've got it, okay? You've done it a million times. You're completely ready. It's just about finding that maths inside. I love this question. I had to put this in. What fraction of the garden is planted with carrots? This is the exact same question as just now. You're given one chunk in a fraction, another chunk in a fraction, and asked what's left with different denominators. That's exactly what's happened here. You've got 2/3 in a chunk. You've got 1/4 in a chunk. And you've got some carrots. I'm going to put C in a chunk equals 1 whole. And you need to work out what the carrots are. This is slightly harder because you have to change both fractions. What's a number that's in the 3 times table and the 4 times table? Well, let's just change them to 12ths. 3 times 4 is 12. Do the same to the top. We have 8/12 is for the potatoes. Not equals, Dylan, no. Now we have quarters. We're going to change that to 12ths. 4 times 3 is 12. Do the same to the top. I get 3/12. Plus something equals 1 whole. Okay, so 8 plus 3 is 11. So I'm going to go up here now. 11/12 plus something equals 1 whole. Well, I know 1 whole will be 12/12, so that's just 1/12 left over, which means I write 1/12 in here. Notice my answer has a denominator of 12. At no point in the question was the denominator given 12, but I have such a solid understanding of fractions that I know I'm safe with that as an equivalence. Let's take a look at this one. Jack buys 1.5 kilograms of potatoes and 0.5 kilograms of carrots. We're given a price per kilogram, so we're going to have to use the fractions to work that out. And how much change do I get from £5? This question is in here because it shows you how, yes, we can have a fraction question, but it can bring in other aspects of maths as well, in this case, money and change. Let's work out how much the potatoes cost. 1.5 kilograms. So 1 kilogram is £1.50. So really, I want to work out what 0.5 kilogram would cost. So I need to do £1.50 divided by 2. I'm going to use bus stop just to make sure. put my decimal in, the 1 goes over, 2's into 15 7 times with 1 left over, 2's into 10 5. So that's 75p. So I'm going to do £1.50 for the 1 kilogram and 75p for the half. And this will give me a total of £2.25 for the potatoes, 1.5 kilograms. Now let's work out half a kilogram of carrots. That should be easier because I just halved that price, £1.80 per kilogram. So half is 90p. So I have £2.25 plus 90 pence. That's going to give me how much it cost. So 5 in the 1p column. In the 10p column, I have 11, so exchange over, and I get £3.15. Very tempting to put that as my answer. If you did, you'd get 0 out of 2. That seems harsh because you've done so much good maths. Well, there's a reason. To get 1 mark in these 2-mark questions, you have to show every single step, and you haven't even tried to do any subtraction yet. So we can take 5, which is £5 with 2 zeros, 3.15, and we can subtract. The reason this tricks a lot of people is because we have 0 take away 5, people just put 5, 0 take away 1, people just put 1. No, we have to exchange here. Get some 10s here, exchange again to get some 1s. 10 take away 5 is 5, 9 take away 1 is 8. Put the decimal in and whack a 1 down, £1.85 change. We can see here how fractions can be combined with another strand to make the ultimate question. Yes, the ultimate question. This is probably one of the hardest fraction questions I've seen, and I'd love to have a go with you guys. So remember, you can try these out yourself, but I'm going to model exactly how to do this. The length of a day on Earth is 24 hours. The length of a day on Mercury is 58 2/3 times the length of a day on Earth. So let's write this down. What this is essentially asking us is 58. No, not multiply, because we haven't even written the whole thing. That would have been a mistake, wouldn't it? Straight away. Oh my gosh, my screen's moving. You get like an earthquake here. Right, let's try again. I'm going to just cross this out completely. Let's rub this out. My screen was just shaking. I want you to comment down below right now, shaking screen, because when Hayden sees it, he'll think, what on earth is going on? So if we can whack the comments. If you got this far, shaking screen. Let's make people confused. 58 2/3. I forgot this last time. Multiplied by 24. Oh my goodness me. The best thing to do here is to split it. Let's do 58 times 24. 58 times 24 is going to be long multiplication. 4 8s are 32. 4 times 5 is 20. And we add on that 3 for 32. So it's 232 there. Now we put a placeholder in for the 20. 2 times 8 is 16. And then 2 times 5 is 10 with the extra 1. Let's add this up now. We get 2 in the 1s, 9, 3, and 1. So here, 58 multiplied by 24 is 1,392. Okay. Now, the other side would be 2/3 times 24. Something to know. Really interesting, actually. It's a good fact. Multiply and of can be changed. So 2/3 times 24 is the same as 2/3 of 24. Now, if we're really strong and confident with our fractional quantity, this should be easy. 1/3 divided by 3 is 8. So I need 2 of them, which is going to be 16. So I have 1392 plus the 16. This is going to give me the total hours. 2 plus 6 is 8. 9 plus 1 is 10. 3 plus 1 is 4. And then 1 drops down. 1,408 hours. That is a long day. That is a long... Imagine doing a day of work on Mercury. Whew. Did you have a good day at work? Yeah. It was really long. It was like 2 months long. My goodness me. Guys, if you got this far in the video, I'd love you to like the video. I'd love you to comment down below, like I said. And I'd love you to share this video with someone you think it would be useful, because we think it's useful. We love doing these videos for you guys. We want to share it with as many people as possible. It's your go now. So yeah, I want you to put shaking screen down below, but I also want you to give me an answer to this question. 3/4 plus what is 7/8? Can you work it out? Have a go, and I'll see you next time.